Hello everyone, I hope you still have some energy. Hope you enjoy Android Maker. Then welcome for this session about dependency injection with Koin and many topics to get around today. I'm Arnaud Giuliani. I'm co-founder of Codzilla, company that has been created for Koin and open source, Kotlin open source. Then I'm the project lead of Koin and also Google GDE for Kotlin. Perhaps an icebreaker. Who is using Koin in the room? Oh yeah, almost everyone. Who is making Compose in the room? Okay, fine. All up to date. Okay. And who is making KMP? Okay, third of the room then. Okay, that's fine. Cool, then some good stuff to share with you today. The idea really is to cover the ecosystem, the Kotlin ecosystem with Koin and show you how really Koin helps you every day with that. Before going into some code, I would like just to shout out about Koin today because then Koin has been created in 2017, then 7 years ago, and still really rocking for many apps on the App Store. And perhaps you have your applications here, but this is some of the little applications that Koin can really power on the App Store. And Koin is really between 3,000 to 4,000, 100,000 applications of the App Store. It's 7 million downloads per month. And that's really big and staking really lots of increase every year. That's really small player, okay? That's fine. Before getting into some really strong topic today, I would like just to get back into the basic Kotlin injection. And well, seems that most of you know Koin, but really, the idea is really giving you the most of Kotlin and helping you making dependency injection. And then this for all the kind of Kotlin application you can do. And Koin is a DSL, primary, a container, and an API to help you request your instance inside. A quick sample, not too boring, I hope. Then just two components we would like to set up, and then we just have a module that we configure this way. You just write module, open a Lambda expression, and then you just use single of keywords to declare your two classes here. What you may notice is that we directly use the constructor of your class. The double semicolon character is kind of a pointer to a function or a class directly. Then here, you just give the class to Koin, and then we fill the constructor, we fill the function, and then we can fill all the dependency with you. Also, you may know from the beginning the DSL expression with lambdas, then yeah, this is a hit. And then finally, you just have a module, and then you use start Koin function. You start the container, then you start your configuration, you give the module here, and then you're done. Yeah, pretty straightforward, pretty easy. And then at the end of the story, you just need to bootstrap your MyPresenter instance somewhere. And then this is where finally you integrate Koin in any kind of ecosystem. You could even ask Koin to pre-create something and then make your main entry application as a bootstrap with the create instance parameter, but we'll see that. The main objective really for Koin is really to make your life super easy and make you super productive. And really this is clearly our main objective for everything. The big thing for Koin has been to be really magic with the Kotlin extension system. If you remind a bit about that, here we are changing the kind of instance. We just have barely two kinds of instance in Koin. We have singletons, single, and factory, stuff you just create and then you can trash and you don't want to care about after. Then let's take a factory because we want to give that to our activity. We have our module. In our Android application class, our entry point, we start Koin, and then in the activity, we have to do something to ask Koin to give us the request of our dependency. And then this is the famous by inject delegate expression. That is finally a Kotlin extension to help you request the needed class instance. Then my presenter here. The big stuff that really pushed Koin really up in 2017 was to provide view models API out of the box and really easy to use directly. And why? Because then with just a keyword view model off, we could create a special instance for your view model. And then what you just have to do is use by view model, a delegate to create your view model, bind the lifecycle, and make all the plumbing for you. And finally, it was a good idea because Google is still using by view models and is still highly using this plumbing for HILT. Then finally, that was a good stuff. In the big picture, finally, you can make distinction between constructor injection function where you declare it in DSL and field injection where you just need a lazy delegate expression. And finally, this is where you are mostly using this kind of locator approach. Because why? Because you are using an API. You are depending on an API. But 80% of your configuration is using constructor injection or function. Now, perhaps you may wonder how you can scale. How you can scale your business application with that in a safe way. And there is many really big topics you need to take care about to be sure that you really be safe with your application and your development. Then around testability, configuration safety, and how you can scale over your application getting bigger and bigger. First time, just I want to remind is that comparing to an application that is using Dagger, even Dagger HILT, you are saving up to 75 to 80% of your compilation time. That means that if your application is taking 20 minutes to compile in Dagger HILT, it's just 5 minutes with Koin. That's really super interesting. Also in terms of performances, when we talk about performances, we talk about a request in Koin is it's between 0.005 milliseconds to 0.01 milliseconds to retrieve your dependency. Then fair enough to say that, yeah, what's the matter of speed here? Finally, we get things really in a fair, fast time, then depend really if you are using a real-time application where you are really under the milliseconds or not. But then retrieving your object in 0.01 milliseconds, it's kind of okay. To help you ensure that your application is safe, we have test, API, mocking, overriding, then you can play with your modules and then puzzle it in the way you want. But then also there is APIs to make your configuration safe with just a JUnit, because this was the deal. Finally, we are unlocking the compilation safety mechanism to give you the possibility to check your configuration by a unit test API. Then, at the end, what you just need is just open a JUnit, you just use a module, and then you run .verify in your module, and then we can run all the configuration checks on that, and that's it. Not really super complex to do. The magic behind is that this kind of API is using introspection on the test side. Then for the test unit, then we are looking at everything that is inside your class constructor and fields. You also have the pending for Android Verify that lets you really do the same, but really highlighting and whitelisting some type from the Android world, like context parameters and so on. Just note that check modules, one of the first API that let us really make configuration safety, has been really hard to get something really done, and it was super complex to use. Then we prefer really to deprecate this API and try to propose something really more helpful and really easier for you to configure, because then else this kind of API where you have to provide every kind of case of safety is really hard for you to use, but also is prone to breaking every time you change your configuration. Then that's not ideal. Koin can go for the compile time safety too. And then you have Koin annotation for that. Why Koin annotation? Because there was two needs for that. There was a need to provide another way to give you configuration by annotations. But the fact that you can make annotations configuration, then we have meta information at your class level. And then we can really understand what you write on your class And this is not the case with DSL, where finally we don't have meta information on your application and class. Then really, if you want really to go to compile time safety, you can go with Koin annotation that really make the same stuff as Dagger, then taking off a configuration and making everything safe, checking that all links you have written with Koin configuration is okay. Let's take our little example. Then our two components, we just add single on it. Then the idea is that annotations take the same semantic as the DSL. You just declare them with add single. Then you have a class module we name mat module, and then you tag it add module and add component scan, and add component scan will scan all the components for the given package. And then we scan for our two bodies here. The other way to use annotation can be, for example, to tag a module and then declare a functions per definitions you would like to declare. And then this is super easy. This is really straightforward. And then you don't have a super complex configuration annotations to use. Just annotate what you need here. And this is type safe. What you have to do is in your KSP configuration is to add an argument, coin check, config check, and then at compile time, it will unlock completely all the configuration check for you. The overhead is super low. Like, for the idea for KSP in Koin annotation is not to reinvent the creation of dozens of factories like other solutions are doing. The idea is that Koin annotation is just generating the few lines that you're writing by hand in the DSL. And really, what the target is really to continue to ensure that there is a low compile time overhead. The other target, for example, that we really open the project for Koin 4.0 is really having a type-safe DSL. And then this is something we are exploring. Also counting on Kotlin 2.0 that to let us really unlock possibility to give us expression, APIs to really just declare what you want at the DSL level. And then also for us to make it testable and then ensure configuration safety as much as possible in the box. The last part of your scaling that you may really care about is that more you are writing application with Koin, more you have modules, and the problem is then more we need to index metadata for you then. And then your startup time is really growing over time. What you can do is really partly use this loading, this module loading metadata in background, and then you don't lock anymore your main thread. How is it working then? Instead of using module that is directly indexing metadata of your definitions, what you can do is using lazy modules and use lazy modules in the start configuration, and then you just declare those modules as lazy. You don't touch it, you don't run it, and then it will run in background for you. What you can do is ask Koin to wait for the given coroutine job that has been launched. The other part also, you can be notified on the coroutine that Koin has finished all the deloading, and then you can do something. At the end, you can even mix both approach. Like really, you can say, let's load in a synchronous way the main module, the first screen stuff, and then let's lazy load everything else. And then you can have a 2080 approach saying, okay, we just have a lazy and super light loading approach, and then we can load in background everything, and we don't have any problem else. With all these tools, then you can really scale safely with your Koin development. The good thing is that then, with all the feedback of the community, the extension engine and the Kotlin lazy module are getting stable at 3.6. Then next milestone that is coming, and soon Q2, Q3, let's say. And that's a good thing. With the number of people that are using Compose, and that's a good thing, let's come back on what really, how Koin is providing in dependency injection for Compose. This is the new declarative UI toolkit from Google, and then JetBrains take that as a multi-platform framework. Then you are playing with your composable functions, and then we are depending on this new composition system, then trying to skip or over-skipping the rendering of your composition. The good thing is that then Koin brings API for you, for Compose. And even with the fact that Compose brings cache system for every widget, every composable, then naturally your presenter and your holder will follow your lifecycle directly. And that's a good thing, because then perhaps you don't need really much to use view model everywhere. But you can use view model too. Let's see that together. Let's take a composable. We want to have my presenter that we have in the other module. What you just need to use is a default value. Using the default value with Koin Inject is a good thing, because then it lets you, by default, use Koin to inject from the container what you have, but also let you have the choice to give a my presenter instance if you are using a test or if you are using my presenter in another case. You are not 100% fully linked to Koin in this way. And then Koin Inject follow the cache system of Compose. That means that finally your instance that is really bound to my composable, it will follow the cycle of your composable, and then if your composable is completely abandoned or dropped, then it will be dropped too, but then else, it's kept in memory for you by the Compose system. You don't have to rewire complex lifecycle of stuff. And of course, there is the pending Koin view model that lets you wire a view model for this widget. And this one will wire for the complex lifecycle backup by activity or fragment or your navigation backstack. Then two simple APIs that is quite super easy to use directly. Finally, we can differentiate those two cases. State holder, where finally you can rewrite your local presenter logic, your widget, your stuff. And then the view model, where it's the big screen logic, the big business stuff that you want to dispatch in your screen. Then finally you can organize yourself in this way. And then you have Koin Inject with the factory. You need to use this as a factory. And for the view model, you just use the Koin view model API with the view model keyword, and that's fine. Let's look at now how you need to set up your context with Compose, because then here you are accessing accessing instance, but then you need to just look at the way you are setting up the configuration. Usually you have your composable entry point, and then this is where you are writing your first composable, and you go in the child nodes here. If you don't use any kind of setup we'll see together, then you are using the global context and no optimization with the local composition system. That means that finally you will use directly a static access to the default system of Koin, which is not so okay. In Compose, what you need to do at the root of your Compose application somewhere is really identify that you are using a Koin context to really benefit from all the scope and the cascading scope of your composable instance injection. For this, you have Koin context that lets you say, okay, in Compose, wire me with the default context, and then put that in the local composition. The other one is Koin Android context. The same, but also looking at the closest Android application in the space to wire everything. This one can be useful if you are using end-to-end test integration, the UI test, for example. This one, the Koin application, is a new start entry point. That means what? That means that really at this point you are starting a new application context. Then, for example, if you are using start Koin in your main entry application class, and you are using Koin application in your composable later, you will have a conflict, and then you can't really have both. Then you need to understand that this is starting a new entry point for the global Koin context. And then if you are just only using Koin application inside an activity, for example, you will have restart conflict because then it will try to restart your entry point directly here. And then, no, you already have started your application. This is the kind of error you will have. Start Koin context has been already started. Then, if you have this kind of error, go back to Koin Android context or run context, and then you will solve this effectively. What is interesting with Koin application is that you can use it for preview. When you want to preview a widget and directly, and you have a configuration of composable that are using, for example, view model or an injection, you can use Koin application inside a preview composable and then just use some preview model and content, and then you can use it to inject the content you want to preview. That's a convenient way to really use composable and add preview with this kind of stuff. Lastly, you can do SDK, Compose UI SDK with Koin. That means that you can completely isolate yourself from any kind of usage outside of your application. For example, my SDK app is a composable that I want to provide to my customer. Then what I can do is using Koin isolated context, and then my Koin context will be completely isolated and no one will see what I'm really doing inside. And then the SDK is its own space of memory. And then it's kind of really super interesting because Compose allows you to make all the UI, and then Koin behind that ensure that you are completely isolated in terms of space. And then for those who are making SDK, this can be a good solution for you then. The isolated context variable, this is a static variable or variable of your SDK, then you need to pass. At the moment, then you need to start your SDK. The good thing of that, with the evolution of Compose, is that Koin stayed really compatible with other kind of approach and frameworks that really try to bring you features around Compose. For example, Circuit from Slack and Decompose, they try to bring you a model and a way to have presenters and navigation and stuff around, kind of architecture on the top of Compose. Then Koin is still interesting to use them because then it helps you to wire everything just behind those presenters. Because finally, Circuit Decompose is a way to tackle complexity instead of view model with kind of presenters. In details, really, if you want to dig into more detail for Koin and Compose side, look at state hosting on Google. There is a good article about that and why you should use state holder, why you should use view model, really to help you have the right granularity of design. Navigation, then Koin really have the navigation capacity for the Android. You also have interesting features like scope. Then you can really have inner scope inside Composable, and you can also load the modules for a proper composable. Like for example, if it's a route, you can say for this route I'm loading this module, and then you can load and unload the module directly on the fly, directly for your application. I don't go into details with this. Lastly, you need to take a look at baseline profile, because then it's really optimizing all the execution for Compose and all the just-in-time compilation stuff. Then look at this because you can really increase like 50% of your startup process. The good thing of that is that, yeah, Compose is multi-platform. And really, it's really super interesting to see the promise that really JetBrains put on the table behind that. And that's a good transition for the next session about multi-platform with Koin. Because finally, well, multi-platform with Koin is just Kotlin code, no? Then shared code, you have shared module. It's not more complex than that. Then if you want to make multi-platform with Koin, then your module, you put them in your KMP project in the common space, and you have shared module. The idea behind that is that perhaps you may have API that are using native side of the native part, and then you will need some native implementation depending on your module implementation. Let's take an example. Let's make a common module. Then I can describe everything with my DSL, single, or even annotation if you want. Then JSON or JSON API or HTTP client. Then it's pure KMP API. Then I can use it in source common code part. And then on new Android application or iOS application, on the Android application, you can use directly the includes to include it directly on your application. On the other side, you can use the expect actual mechanism of the multi-platform side if you need native implementation. If you see John's talk this morning, he was taking the same code aspect about SQLite driver, because then for SQLite, for the database for multi-platform, you need to implement the right driver for the right platform. Then in the command code, we say we have a module, and then on each platform, we say what kind of implementation we have. Then we have implementation for Java driver on this way for Android and JVM. And on the iOS side, you have an actual implementation of the platform module with the right native SQL driver, etc. Then this is took from the People in Space project of John that is really highlighting everything for the KMP side. Then you have both implementation to provide. And then because in the command code you will have platform module, then after that you will choose the right implementation for you. But that's not finished, because then you need to start from somewhere. From Android it's quite easy, because then it's still Kotlin, and then you start your Android module and then include it in your common module. But then on the iOS side, how is it going? Usually what we do is we do a wrapper class, a wrapper function, to let us start the common configuration that we want to start on the iOS side. And then for this, we have a function in Koin where we are starting the minimal configuration that we want to use on iOS or on all the platform. And this, after that, can be used in your iOS application as Swift, because then it's a static call to the Koin Ktor class, do init Koin function. This is the translation that Kotlin KMP is doing with the previous file, where you have just a function, init Koin, in a file called koin.kt, and then this will make the translation for you, and then you can call it directly. And usually this is how we are starting dependency injection on the iOS side for the shared part, that finally we init this part at the start. Problem, how you inject on the native side now, because then it's not Kotlin. And then if it's not Kotlin, we don't have extension, and we lose part of the magic of Koin then. Let's see a few patterns about that. You need a wrapper for that. What you can use at the beginning is an object class. We have, for example, Kotlin dependencies, and let's say manually you will expose all the entry points you want to use on the iOS side from the shared code side. And for example, we want to our presenter. For this class, you need to use an interface marker from Koin that is Koin component. Koin component will bring to a class your Koin context. And then in this case, Kotlin dependency will unlock your capacity to use getCoin, get by presenter. And then statically you expose your instance, and then in your observable in Swift, for example, you will statically retrieve your dependencies directly as a static access. It's not super convenient, because one by one you need to declare all your components like that. The other way, and the other capacity from Koin, and John is really using it a lot in his application, is finally bridging with one of the components. What we really intend by bridging is that finally you will create one component, one class from Kotlin inside Swift, but this class will pull all the dependencies for you. And then you keep the magic from Koin. This class, for example, is a shared repository. And this shared repository, we can use the remote API, and then we inject it from Koin. But this repository then we want to inject it in Android code, then we can inject it in constructor in our Android view model naturally. And on iOS, for example, what you can do is really create an instance locally for this class, for this view model, and then this class by its instance will pull out all your dependencies from Koin. Then we are using really a locating pattern here, but this opening us also this capacity to bridge any kind of situation when you are in between iOS and Android, where you are in between, for example, Koin and Dagger. It will be the same if, for example, you try to move from Dagger to Koin, you can bridge in the same way with Koin component. Some shared view model solutions. What you have currently, you have KMM view model and you have Moco MVVM, let's say until those days. And this is a community project that let really implement the view model aspect for both platforms. What you need to do is use KMM view model from the library that we are using. And then we are using the same approach we are bridging with Koin component, okay? And then what you need to do is declare view model instance in your command module. And then what you can do is in Android, you say you use by view model and then inject your view model by delegation. And on the iOS side, you need to write a proper extension to declare KMM view model. And then you can use it directly in your iOS view. And then you can benefit from this instance that will create the proper injection thanks to Koin component. Then if you really have to take two things from the KMP aspect and the pattern of injection, you have wrapper, then wrapper of function, wrapper of class to expose directly and statically things. Or you can use bridge component that let you really go in from one world to the other world thanks to the Koin component interface. The good thing of that is that finally for the KMP approach, if you are ready to share everything until the UI, you can use Compose that is already multi-platform. And then everything is in your common dev space. Then that's even better. Except the view model side, I would say, because then, until this week, Koin view model was not ready to go KMP, and also because Google and JetBrains are working on a new API. And this is it. Google and JetBrains are really, Google is opening the API for view model, for navigation, for many other stuff, and JetBrains is making the iOS implementation for the Kotlin part. And finally, this is a good thing that Marcello from Google that pinged me on GitHub and says, hey, we can really unlock the view model capacity now for multi-platform. And that's a great thing. Because finally, since Compose 1.6.10 beta 1, they are really going super fast. If you follow really Compose release, there's almost a release every 2 weeks, then yeah, they are really going super fast. But then they are unlocking lifecycle and view model API at the multi-platform side, which is really a great news for that. The interest for them and for both platforms is to share this lifecycle complexity and then map everything for all the developers. And then here it's the Jetpack lifecycle system. And then on the iOS side, thanks to JetBrains, they are mapping all the iOS side, and then we just handle a main lifecycle process that is on stop, etc., etc., etc. And then the good thing, finally, is that view model API, view model will be shared completely thanks to this API for your application in Compose. And that's a super great idea. Then, yeah, lots of work to come. Thanks. Still, KMP is still sharing things from Kotlin to Swift to iOS in Objective-C, and then Kotlin 2.0 is bringing lots of Swift portability for that. Then it will really help us improve the developer experience. And also, if you are targeting WebAssembly, then Koin is already ready for that. If you are ready to use a bleeding edge release of Koin, then it's 3.6.0 beta 3 from yesterday. And then you can use WASM implementation of Compose and Koin, and then make some dependency injection. Then John is already using it, then thanks. And that's good. Is there any people using server-side development here? Who is using server-side? Oh, a few ones then. Then Koin also is ready for Kotlin server-side development, thanks to Ktor. Ktor, this is the web development, the server-side development from JetBrains that tried to propose something really in the Kotlin language approach, super easy and super fast to write. What you just need to do is set up the Koin plugin inside your Ktor application and then inject in a web route that you want to have. Let's see that together. This is how you begin to write a Ktor application. You need to extend application and write main point or your module. And then just use install Koin and then you will install your Koin configuration. Not complex. And then you can use, by the magic of extension from Kotlin, you can use inject in any part of Ktor, in the root and the configuration. You can use inject everywhere you want, and it's a lazy delegate one, as usual. And then when you are writing some server-side routing, like this one, you are /hello, get on /hello, then we can really inject our repository instance in this way and then use the instance of our repository in a super fancy way. In terms of performance, this is super, super fast because there is no introspection, no class path scanning, no code generation. And then even at Codezilla, we are using in production, and then we can restart our servers in a few milliseconds. Then that's really super, super fast. Then it's really interesting in terms of serverless development. The other side, you can use the default aspect or the isolated context. This is how Koin is working. But then if you are in position or you want to launch several Ktor server application in parallel, you can. You have some features like request scope. That means that you have created object from the lifetime of a request. And also you can test easily inside. Let's test our little application. This is also a generic way to use test for Koin in a parallel way. You need to use Koin application, a local variable Koin application with your modules, .koin at the end, to keep the Koin instance of your configuration. Then what you need to use is a delegate approach with Koin inject, and then all your field, everything you want to use in your test will be lazy injected, and then you can use it. At the end, all your configuration, at the end of this test, the configuration is dropped. Then it's kind of easy to run in parallel. And then in your test, my repo is ready. In Ktor, then you can use it to make service-side integration testing, then just testing at the service level, not yet at the web service level. If you want to test at really the top-bottom web level, then you should use autoclose Koin test. That is a class that allows you to stop and start your context depending on your stop and start your context. Why? Because finally, test application. This is an API from Ktor that will run your Ktor application and your Koin configuration. And then you don't have to run by yourself your Koin configuration inside the test. But then, if you want to rerun the server, you will have to close the Koin context also. And then test application, we test or get response just to be sure that it's hello at the end, and that's it. And then naturally you are using Koin inside this, and you don't have to set up anything else. The good thing is that JetBrains is investing a lot in server-side development for Kotlin, and then there's a big roadmap update with a line about dependency injection. What really they are doing is that they are really making a collaboration or preparing the ground to have a plugin to be ready to use configuration for Koin directly out of the box. They try to detect your Koin configuration, and then you don't have to run anything from that. And that's kind of interesting to have a more efficient way to develop with Ktor. Then that's a cool thing. The other stuff that really I'm starting to talk with JetBrains team is really to say, okay, how we can pre-bootstrap instance with Koin and how we can create things out of the box without doing anything. Kind of really magic bootstrap of instance inside any kind of application. And on the server side, for example, they just want to have pre-configuration of some part of the server without having to declare it manually. Also in Kotlin 2, there is new things coming. I'm not sure it will be in Kotlin 2.0, but 2.1. It will be context parameters. They try to revamp what is context receivers with context parameters. Why? Because context receiver is making lots of conflict with your current scope of your application. In clear, when you are using this and rbase something, then you have rbase on many kind of scope of all the parameter scope you have, then your function and many other stuff. Then that's a bit blurry, and then people feel a bit lost about that, and then they are making things explicit for that. Then that means that we would perhaps don't need to use by injecting Ktor, thanks to this new approach of Kotlin 2. Lastly, also, they really invite all the Ktor community to produce a plugin, and then you will. The idea is to be in the catalog for Koin, to be in the catalog of the Ktor plugin, and then you can download any project and then pre-configure your Koin plugin. Really interesting. Okay, it's time to conclude, and here you can see it's updated. Then this is the community, the last people that are contributing to Koin, and I really thanks them to all the work they are making, because they help me really make Koin better every day, and thanks to them. That's really super important. And you can reach the community on inside Koin.io, on Slack, Kotlin Slacklang, inside Koin.io, on GitHub, etc., on Twitter also, X. It's important that we have your feedback, because without your feedback, we can't really improve things. But then if you have any issue, if you find things really weird, reach out, and then we will find solution, or we can give you answers, of course. Everything I've shown you, you can look at the setup section inside Koin.io on the web page, and you have all the setup instruction and quick start tutorials. Then you can play quickly with Koin and all these API, perhaps you don't know. There is the Now in Android with Koin. There is the declination of the Google Now in Android application. This is the sample application from Google, but no hilt, Koin, it's better. And then you can work with that. You can find also on Codezilla.io, there is all the article about the migration about that. But in this repository, you can find the migrated version of Now in Android. Perhaps to give you more things, to have more matters on what's going on the Koin community. Koin is working by a cycle of 6 months. That means every 6 months there is a new version, and then we need to go to the next version. And then in terms of community, then we can't really hold all the version for everyone. That could be unmanageable, and all required timeless development. Then currently, the last version, 3.5.6, is the last of the track 3.5. And then soon we'll land the 3.6 version, bringing lots of new compose optimization, for example. This year, lots of stuff to do, you see. It will be kind of interesting, like working on the lazy module, verification API, also reusable instance, like trying to reuse something that we created with a factory, but in the thread and not being garbage collected, some kind of weak reference instance creator. Of course, all the new view model for KMP, Compose, injection POC, etc., etc. Koin annotation really is getting better and better, and really needs improvement to continue to be improved on those, to be really to really offer the same experience as Koin. Also, there is KSP2, that is the new version for KSP for Kotlin 2. Then really need to check that and see how it is breaking, because it's not working well at the moment. And we clearly try to open a new branch, Koin 4.0, because then we want to open a new role for the new language, the new version of the language, and then new capacity, and then benefit from that in a new version of Koin. Then for us, we can really clean up all those deprecated API we have since years. Then we can clean it, and then we can try to work on new engine, and especially on a new type safe DSL for you. That's pretty much it. Just a last minute to say that finally at Codzilla we are offering official enterprise support, that we are working with company helping them about Koin and development, but especially we are offering also a long-term support program to help them really keep working on Koin for more than 6 months. Then that's a good thing for people that really can't update every month, for example. And we are currently working on a new platform, a new dev platform at Codzilla, where finally the idea for us is to understand all your architecture data, analyze it, and then help you work on debug and production side and analyze your data and help you maintain it, then optimize it. A few customers that are working with us currently, Plum, for example, this is a financial application, and they have a stateless architecture, and then that's interesting because then with our platform we can monitor how much instance they are creating and what's the velocity of the screen and how much things they are creating. What is the cost of their stateless creation? Liberty Rider, for example, this is a transport application where they have problems integrating third-party libraries, etc. Then we help them monitor all those integration, their architectures, and internally their SDK. Then that's a good thing because then not lots of platforms allow to really monitor only the SDK part. And lastly, our friends from Canal+, we help them monitor their architecture, earn performances, object creation, and scope tracing. The things we are trying with them currently, everything you want to, you can check everything on Codzilla.io. And thank you very much for your patience. I don't give QR code this year because I believe it's always hard to try to take photo of QR code. And if you want to reach out the team, then it's on am24@codzilla.io. If you want to ping us, then it can be easy. Else, I believe we can have time for a question. No? No time for the. Then I'm out of the stage if you want to reach out for Koin stuff. Then, thanks.
For those who are living